Okie doke. Let's go. Make it for the mistake of only getting 20 minutes in yesterday. Got preoccupied. Mistakes. Let's fix this. Let's get back to being good. Okay, last time we had destructors, right? Timing. Oh, this is just talking about destructors and shit in general. Yesterday we did an example where we made a class, and the class has, let's see, the class has a constructor, and the constructor takes the size of the dynamic array that it's going to be allocating. Or I guess memory is allocated for the array, something like that. That it's going to be initializing something. It's the size of the array, and it's a dynamic array. So an array that's created from dynamic memory allocation via malloc or whatever. I mean, in this case, we're using new, I guess. Yeah, we're using new. So we're getting the memory from the heap. And then we have a destructor that once the destructor is called, when the object needs to be destroyed, like when the function, if it's a local variable, when the function it's in returns, all the locals get destroyed. So the destructor gets called, which means it has to free up using the array version of delete. It has to delete that array. Otherwise, the memory that was for it was real cold, so I was smacking, my fault. Otherwise, if the memory isn't freed or deleted, then we get a memory leak. The memory is still being used. So if we call that function again, it's going to allocate more memory, and then that memory is going to be used during the lifetime of the program. And if it's still not freed up, we're going to get even more and more and more. So if we looped over this, the program would get more and more memory expensive. Because we're using memory without cleaning it up. Okay. Yep. And so the benefit of this is that if we don't know the size of the array, then we can't use a standard array or a C style. So we either have to use a standard vector or a C style or standard array, dynamically allocated. Yep. Yep. Otherwise, the syntax would be confusing, because for standard vectors, we can use parentheses to pass it, or to create a vector of that size. But if we do list initialization, it instead looks at the value to be assigned instead to an array. And if the value is only one integer, well, the array is only one integer long. So value initialize 10 elements by doing parentheses 10, or list initialize one element with braces 10. Constructing simple, and then printing the ID. 1. Then doing it again. Oh. So we create a temporary, we create a dynamic simple. So we have a pointer to a simple called p simple. We initialize it with a temporary simple. So we create a simple somewhere in memory, and it's new, and that value is stored in memory, and then we are storing a pointer to it. And then we do, so we've created another simple. Yeah, so it's simple, ID 1, and then creating simple, and then ID 2, and then deleting. Hold. Oh, yeah, 1, and then 2, 2. Oh, and then deleting simple means that we're calling the constructor to free. So it's going to free when we delete p simple, it says that that one needs to be destroyed, and then that dynamic one. So the value at that pointer location gets destroyed, and then the first one is destroyed. Okay. Excuse me. Yep, we know that for global stuff. Yep, sure. Same with static. Oh. Resource acquisition. It's not resource allocation, it's resource acquisition. What do you mean by resource acquisition? Like memory allocation? What are you talking about? Resource use. Resource use is tied to the it's tied to the lifetime of objects with automatic duration. Meaning that we have objects that have automatic duration. And those are the objects that allocate memory. We don't just allocate memory straight up. Memory, a file, whatever, is acquired in the constructor. So when I initialize a system that lets me read and write to something, the constructor sets everything up. I can use it while the object is there, and then it's unset up, it's deleted or disabled, in the destructor. Gotcha. So the point is, whenever we're allocating and deallocating memory, we're doing it in a constructor and destructor. Oh, that makes sense. Yeah, that way you're not calling a function, and in the function, you're just allocating memory. You're instead creating an object that allocates memory for whatever you need. Like, maybe a class is never big enough. Like, for a class that's big enough to need extra memory, you just create an object of the class, and it has a pointer to where the memory is actually going to be used. The rest of the object isn't big enough to need it. So we create the array. So we call the constructor for the array. The constructor, we have a targeting system, and we create a targeting system and we pass it the 10 targets, and then in the constructor, it doesn't, not even in the member initializer list, just in the constructor, we take that array of shit and we copy it into, right? And we copy it, we pass it by reference, and we copy those values, just one copy, into memory that is new. And we can use that, we've used that extra memory, and then once the tracking system is discarded or deleted, then free the memory in the destructor. Huh. See if I can make a copy of standard string in a sec. That shit's just so good. Uh-huh. Okay. Trying to think about how to pass. If I pass it a literal, is a grouping of characters treated as an array of them? I guess so, right? Okay, so what if we do this? Okay, so what if we do this? Alright, I'll just start with the constructor. Oh wait, it's just a pointer to characters. The point is if we're receiving, like I want to create a string like this. So we're passing it an array of characters. But the thing is, I don't know the size from this because when I pass this, we're going to be dealing with a pointer. So I think I have to loop through it to figure out the size and then dynamically allocate that size. Excuse me. I think I have to just do this. I see, but I is less than what? I mean, do we do while true? Hold. We don't know how many loops we're gonna have, so I'm gonna do a while true. And we're gonna say and I is 0. Or we could say, I think maybe I have to do this first. Int length is nothing. We need to check if we're in line. And eventually length will be the length we need. And once it is, we'll do mchars is, right? The new character of size length, but I think it needs to be a static cast to a standard size t. And I know I need to include real quick. Should have gone the other way. And there's the point that we want to... I don't know how to get this guy by reference either. That's the hard part. What if I did that? No. Wasn't it like... that? Something like this. Hold. And so const is fine? I guess so, huh? Because... so it's treating these as two separate... so... we can't lose the constness of the array, seems like. And what if I did reference? No. Okay. Right? And then we also need to match it. Right? Because we want to copy those guys into memory. What do we want to do? So we could do... Okay, so we loop until we get it. Once we get it, we can break. If we don't have it, we need to increment it to try and get it again, but eventually we get length to be whatever it needs to be. And then we allocate enough memory because we know length. And then we need to loop through and copy values over from this known array to this next array, our array. And then we need int get length, const return length. What do we want? Oh, and actually, this is fun, I think. Well, and really we could just do, it's a string, right? So question would be, how do I get it? How do I get the whole string? I mean, we can only use it as a pointer, kind of, right? Like, I can't return... I mean, what happens if we return the whole thing as an array? Like, what if we did character... Well, no, there's no name, so it needs to be... I mean... I could save it as a pointer and then subscript it, right? So I'm pretty sure we need... Do I need to get it as a const though? I don't know if we care. I mean, I can return a character pointer, like get string. But I mean, we already have it, right? The point is this is a string, and I can print it. I can void print index in index, and then it outputs mchars index. And I guess we can assert. Oh, what the fuck am I doing? Include C assert. Assert. And so we could assert that the index is valid. Assert that index is less than length. And really this should be m length. Uh-oh. Where? Here. So print index. We could void set index. So you could say index and then set to be the index and then the character in index character new character. And this can be const because we're not changing anything. This can become same. And then what would we return? No. Can't overload the assignment operator. Oh shit, that's equivalency operator. Excuse me, can't overload the assignment operator either, I guess. So we'll set the index, so we'll say assert that again, the index is less than m length. And then m characters index is now a new character. Set character at index. Print character at index. What else? Oh, can't we get character at index? I'd rather do get index. Why are we outputting it? Shouldn't this just be a character? Oops. Can we also do find? Find the target. Do we return the bool or do we return the index? So I could call. Yeah, I guess we could, right? So we could say int the index, right? So we'll say for an I, probably while I is less than m length, increment I. But how is it so cold? Did I make sure that I turned my AC off when I left for work? This is kind of crazy cold. Oh, passion fruit's no joke. Be back. Okay. So I want to search until I find it. And so we'll say if no characters I is target, then return I. And if we go through the entire loop, do we do a standard optional? I think we do that. And so instead, this is a standard optional that returns an int. And I think if we had this being an int, I think I could do that. Like that. And then, so we can return the optional. Otherwise, return standard null opt. What about return null opt? No. I could, what if I did using standard null opt? No? Return null opt? Oh, cool. Just fucking around a little. Oops, what am I doing? I'm deleting. Nope. Oh, that's much better. Okay, just use X to kill lines, no more backspace. Okay. Turn standard null opt. Not found. Return empty optional. Loop through characters to find target. So, and this could be different. So instead of print, let's just make this a standard OStream reference, an output stream, operator insertion, standard OStream reference, because it's the left operand, OStream reference output, and then a string, well, a string reference string here, or this. I don't know how that works. No? Pointer to this? What if we said that? Huh? No? I mean, I could have this on the outside. I feel like we don't want this here. So you see, too many parameters for this operator function. It returns a standard output stream, operator insertion, standard output stream X. Like, I don't know why it's doing this. So if we removed it from being a member function, because I don't think it needs to be, now it doesn't have any issues here, which is interesting. Okay. And so I'm going to do we could get the data, right? We could get that pointer. We could find a character. We could set a character. Get a character. Get the length. I'll do that. Why not? Kind of like can I change the color of the text? Dang. Okay. So we could say data. Right? Just return M characters. Does it need to be const though? I don't think it makes a difference. I'm not outputting anything here. Why not make it const expression? This probably can't be because there's an assert in there. No? Maybe not. Oh, I guess that was the thing that I saw before, where you'd be surprised that, oh, I can have assert in a function. It's calling a runtime only object function from a const expression function, you'd think that no control path would be evaluatable at compile time. Hold. What the fuck is this? Okay. So we could do, I'm going to output x's length, x get length, and the line. What? Get a character at an index, or get character at index? Get char at index. Well, we could do a standard optional and we return null opt. But then we have so many things we have to evaluate. Let's just do an assert. So if we're out indexing out of range. So we'll do second index's character is so we'll say x's character at index 2 is x get character at index 2. And then what else? So we could find something, so we could do not t, but we could do, we could do lowercase t is found in x. T is at index x find t. Hold. This is going to throw an exception if we don't find one. Or, no, sorry, yes. Instead of it being undefined behavior, if we just dereference it if it's not found. Cool. And then, what else? We could say, I could print all of x. So far, we could also do, we do x set index, set index 3 to be z, and then output x again. What else? Data. Okay, so we can print x, we can get x's length, we know it's 4. Well, I guess we'd want it to be the inline character, huh? Because if I create it and it doesn't have an inline character, or is it implicit that there is one in here? Right, because wouldn't this go forever? So if we passed it this, yeah, it sees that it has 5. So if we put some number of characters and then put it in braces or in quotes, it actually adds the null character. Nice, that's great. The null terminator. I was gonna say, because otherwise we'd put it in, we would see, okay, we get a pointer to character, and then to a const character. I guess that matters. Oh, because if this evaluates to be a pointer to a const character, then we can't change it to be a pointer to a character, because this is the same as this, which is why it still works. It's just how C-style arrays work. Okay? And then we have test, so it has length 4. The character at index 2 should be lowercase s. And then in x, t is found at index 3. And then I can set it. I can set the index. I set the third index to now be z. And now it's that. Okay. That's kind of a standard string, right? Returning stuff by character. I can print the whole thing. And then for printing, but this is getting called every time, right? So we're getting the pointer and then dereferencing it. I think we may as well just do get string data. So I think we just do character or a character pointer to a character or pointer to a const character or sorry. Oh yeah. Character pointer called data, and it's initialized with string data. And then instead we're calling this on, well, hold. And then we're just indexing data I. And that's fine. Same result. That way we're only calling data once here. What happens if we did this? Yeah, no. No, sir. Makes sense. Because it's accessing dynamic storage, right? Yeah, because it's accessing runtime. Okay, cool. Okie doke. That's how you make string, basically. As far as I could tell. Oh, duh. What the fuck am I doing? Alright, hold. Forgot everything. So this is the constructor. We need a destructor now. And really it's an array of characters. And this is wrong. mchars. So it's boom, boom, boom. Yep. Doesn't take anything. And all it does is, do you even give a fuck if it's const? Nah, it does not want it. What happens if we do it? Invalid use or something? Yeah, that makes sense. Okay. And so, well, we could also do a copy. Oh, actually, I guess I can't assign him to be another one. I'll add that in a sec too. Another one. And so or well, I'll leave it like this for a second. Okay. And we use delete mchars. Excuse me, if we're getting a reference to characters, I mean, it's really a cheap thing. It only holds an int and a pointer to a character. So basically an int 64 and an int, because a pointer is an int 64. So it's just a big int, 8 bytes. So we're talking 12 bytes for this whole guy. Oh, I'll get the size of him in a second too. What if we did Hold. Uh-oh. Hold. When? Oh, Sizev's not happy. Oh, okay, good. Exception's happening earlier. Alright, that's good. Oh, it's happening in optional. Oh, but I can see here when this happens. Hmm. Oh, because we're trying to find T. Hold. Yeah, but shouldn't we be finding T? Hold. Yeah, so we're looking for T. It didn't find it? So it returns standard null out. Why? Why isn't it finding it? Then we found T is here. Hold. Wait. Oh, what the fuck? Hold on. What is that? Why did it do that? Hold. Okay, so we'll print X and we get T. The length is 4. This. What the fuck is that? Is it something that resolves if I restart? Just curious. I'm not seeing it right now. Oh, still. Okay, good. So this is fine. The length is 4. Get character at index, is that fucking up? Is it because it's const expression? No. Really? What? For when? When? Why? Whoops. Oh, wait. Get character at index as well is fucking up? How? Why are we calling that? Oh my god, because did we create a temporary? Hold. Oh, because when I printed it. Wait. Oh. When I print this pointer, right, is set with a pointer to here. Wait, but as long as the string is alive and hasn't been destroyed, then it should be fine. There's no other one being created. Excuse me. Wait, why is it destroying the string? Hold. Oh, we're creating a temporary here. Oops, this is not a string reference. We're creating a temporary. Oops. Woo, that was fucking scary. Did I delete that at some point? Just wondering what was happening. Okay. So we have test, we have for. So why was that happening? Let me find out why real quick. So if this is a temporary, then we print, and when we print here, so the standard character output X, so we output this, and then we're outputting, so we output this, and then we return this, and then we output this, and then we return this. But in this outputting, we're creating a temporary, and at the end of here, after we have, after we have evaluated or printed this whole line, then, or I guess actually before, once we evaluate this expression, let's find out. So it's just test. I've printed test. But then so we print test, and then this guy is destroyed. And then we end the next line. So it's we're printing destroying string here, or right after this guy gets destroyed, and then we end the line again. Because it's not test end line, it's test. It's test and then straight to destroying. So this guy actually gets destroyed before the end of the full expression. So I'm not sure when the full expression occurs before deleting. I don't know when the deleting happens before versus after the expression. It sounds like it happens before. So like right once it's done evaluating this first print, then this guy's destroyed. Well, now we get him by reference and we're cool. And I guess I accidentally deleted that. And the size in this case is 16. And it's because a pointer to a character or a pointer to something should be an int64, which should be 8 bytes. And then a regular int should be 4 bytes. But maybe there's a little extra just because it's a class. I think that's what's happening here. I think it's seeing that, hey, this guy is 8 bytes. And therefore, because he's 8 bytes, any extra shit we're not going to add 4. We can only add it in increments of 8. So we add another 8. And then at the very end, we destroy the string. Cool. But now I also want a copy constructor. And so if we get a string here, we're gonna, if we get a string reference, then we have to copy it by value. Copy string by value. I don't want to create another temporary string here. I just want to get a pointer to a character. So I'm going to say a pointer to a character, or a const pointer to a character. Temp is initialized with string data. Hold copied strings values without creating another temporary whole string that's then going to have its own destructor. And then we're going to say, then we're going to initialize this guy. So we're going to, oh, I guess this is when you would want the delegation, right? Fuck, I don't remember constructor delegation. I guess it's not too bad. So we're gonna get a new character, the length of that guy. So we're gonna get a new character, character of the size, string, hold. Why wasn't it? Okay, and that part's fine. So I could do static cast to a standard size t. Alright, copy over string size, and then initialize this string. And so we'll create a temp string, const character, so we don't have to keep calling it, const character pointer, temp string data, and it's initialized with string data. Temporarily store data for copying, and then for an I is less than, oh, I guess we're going to create the size, right? So instead we're actually going to do m length, or here we go. Can I do this? I'm not sure. Let's find out. M length is initialized to be string, oh shit, get length. Can I do that? I guess so. And so what we actually want to do here is set this to be m length. And we're going to say, well, we're less than m length, increment I. And we're saying m characters I is temp string data I. And we could make sure that the length is greater too. So we could assert that string get length is greater than 0. And we also need this. Hold. What's happening here? What the fuck are you saying? What the fuck is happening? Are you tripping? Maybe it's tripping. Okay. Does the assert break it? It's exactly what I fucking typed earlier, but okay. Excuse me, and now we're going to say string y is x. Excuse me, and now we're going to say y. Oh, oops. Y. And it all works. Okay. Warning about standard exit. Don't we have to put the code too? Oh, if we do standard exit, what about abort? Let's find out. Huh? Oh, good. Yep, no constructors called, so abort too. Interesting. Okay. Oh, and that's the important part. So it's fine. The memory is going to be deallocated automatically in the final cleanup, but because the constructors aren't called or the destructors aren't called, then you might not clean up the shit you need. So if you need a log of the errors, it's not going to save and other stuff too. So you might want to have some sort of check first. So like if this, then write to the log and then abort or then exit. Yeah. Yeah, it's nice. Pointers to pointers and dynamic multidimensional arrays. Yeah, we looked at pointers to pointers before. Yeah, I definitely want to do this. How far do we go? Oh, it's not even far. Okay. I don't think I don't think Emma said milk. I was gonna say milk. I'm tired, I guess. Um, I normally don't say either. Well, I'm gonna do some push-ups real quick. Oh, I meant to say not milk, but I don't think music fucks me up if it's the right music. Specifically Noah. One, it's a cool name, and I want one of my kids to be named Noah. One, after this musician, and two, just because Noah's a cool name. And then it just feels holy. That's gonna be the main character's name in my game. Absolutely, bet my life on it. It's gonna be Noah. Um, fuck. I said again. Let's do 15 push-ups and then 15 sissy squats. Moving around. Kind of. I need to be a little closer. No idea how many that was. Probably maybe 13 or something. Who knows? Do some sissy squats. Balance. Oh fuck. 12 more is gonna be tough. 1, 2. Got him, bitch. Fuck. I don't know. 8 more, I think. I have to do this to slow getting old. I'm a pussy, I don't do it enough. Rather, I'm just stupid. And weak. Three. Last one. I'll cook after this. I think that'll be my schedule. Come home from work, immediately do this, and then eat. And I'll be ravenous instead of eating before and then crashing. Okay. Ooh, double, triple. Is he gonna show triple? Oh, interesting stuff. Oh, dynamic. Oh, crazy. So how does that work? Multidimensional needs to be fuck. Like a standard arrays, right? Or isn't it pretty easy in C style with stack memory? And so what does it look like with the array? All right, and then I could initialize this. Or no, I want to store it as a pointer. So what data does this look like? Hmm. Oh. A pointer to a character of 4 with 4 elements. There are 3 of them. 3 rows. If I did that, no? Okay, I don't know. Normal pointer, yep. Pointer to a pointer to an int. So we have a pointer to an int, and then I can point to that pointer, which gets that address as pointer. So I have to double dereference it, right? Yeah. Because we dereference 1 to get the address of the pointer, and then dereference that pointer to get what it's holding. Yep. Yeah, because this would be a pointer to this and a pointer to this. Wait, what? Hold on. Yeah, that doesn't make sense. Because this gets the address of this guy. But then we're getting the address of the value it holds, which is the address of 5, and that's an R value. Oh, what the fuck? A pointer of ints, and there are 10 of them. So it's a pointer to an array of pointers. So it's okay. No, we don't need the syntax. The point is, it is pointing to 10 of these guys. And each of these, so this is an array of an array of pointers to ints. Wow, what the fuck? Oh, wait. Oh, an array of pointers. So this points to this points to this points to this points to this. So the pointers, we could have this whole array of int pointers, 10 of them. And this could be all the targets that you have. So really, I mean, it makes sense to just have an int pointer, and it points to an array of ints. So, right, an array of ints with size 10, etc., right? But instead, these point to themselves other things. And the point is that I could set those to be pointing to other arrays, maybe? Hey, it's what I tried. What the fuck are we talking about? If the rightmost array dimension And the point is we have the array of Yeah, I need my monitor to be lower. I never noticed that. Yeah, it makes sense. Otherwise it would okay. Instead of points, we put the parentheses there, so it's an array of 5 integers, and it's a pointer to an array. An array of pointers. So we have a pointer to a pointer. Specifically, it's a pointer to the first pointer of an array, and it's a size 10 array of pointers. And then for each of these, we index array each element to now be an array of integers. I don't see that as being rows. I see that as being columns. This is an array. Well, this is a pointer to an int pointer. This is an array of pointer to integers. And so we index count. Hold on. We index that array at the count to set that pointer or that array. Hold. Yeah, this is a stupid section. I don't like it. It just seems useless. I can't see any uses for this right now. All right, we'll continue. We'll do this in a minute.